Today we're going to start out working with some pendulum motion. A pendulum is just a object on a string that swings back and forth. Before we start moving with that though, we have to go over a few words that you need to know the definitions of. And if you take a look at your sheet, there are spots on each of those words where you can write down the definition. The first one is vibration. Vibration is just the back and forth motion around an equilibrium position. If you remember from last semester, equilibrium means a state of steadiness where there are no forces that are acting on the object, so everything stays pretty much the same. It doesn't move. So anytime you have any movement or motion back and forth around that center position, it's called a vibration. The second thing that you need to know is a wave. A wave, by science definition, is a disturbance that progresses with no actual transportation of matter. All that's saying is that the energy from the wave is all that's moving as it moves through material. That material itself does not move. The wave moves through it. So whether it's water, solid, liquid, gas, anything along those lines, the wave does not move the matter. The third thing that you need to know is a period. A period is the time of a full back and forth swing. So let's say you take that pendulum and you pull the object that's hanging from the string as close to you as you possibly can, and you let it go. The time that it takes for that object to swing all the way to its furthest point away from you and then all the way back to you is called its period. So the next thing we're going to do is go through and kind of look at some different factors that affect the swing of a bob, which is the object on the pendulum. So we're going to switch over to right here. And over here we've got our pendulum. So if you look, there's a string, and then there's this thing called a bob. And over here it talks about like how high up the bob will swing. Over here you can adjust the length of the pendulum, so how long this black line is. The second thing you can adjust is the mass, so that's the mass of the bob down here. For right now, if you take a look at your questions, the very first one is going to ask you, how does the period or the motion of the pendulum work? So what we're going to do is we're going to leave the mass at 1 kilogram, and we're going to leave our length of our pendulum at 2 meters, and we're going to let it go. And as we do that, I want you to kind of take a look at, does the height of the pendulum change? Does the swing of it change? The angle that it comes in at, is that the same angle that it goes out in? Does that decrease over time? Does it increase over time? Just write down any observations you see with this pendulum. Ready? Go. Okay, so what we're going to do is we're going to pause this, just like that, and we're going to bring it back to center, just like that. So, I hope that you wrote down as many observations as you could. The next thing we're going to do is we're going to add a second pendulum to the mix. So we're going to say that it hangs at the same length, so the length hasn't changed, but we're going to increase the mass to 2 kilograms. That's twice the mass of the first pendulum. What we're going to do is we're going to kick it out to our 50 degrees, right there. And we're going to start them both at the same spot. So let's kind of go like this, where you can see the blue one, which is our 1 kilogram one, is starting at the very same spot as the one that is our 2 kilogram one, so the red one. And I hit the button, they're going to start swinging. What I would like you to do for question number 2 is to note any differences or similarities you see in their motion. Now, these can be differences in how high they go, differences in how fast they go, differences in anything. As far as similarities go, it can be anything that they are similar in. So maybe they both swing to the same height, but they don't get there at the same time. Or maybe they both swing in and out to the same degree, like the different angles here, but they don't do it at the same time. just write down any observations you notice about the two pendulums. Ready? Go. The next question on your sheet asks you if mass actually plays a factor in how these pendulums swing. At this point, you should kind of notice that it doesn't make that much of a difference at all. In fact, it does not play into it whatsoever. The length of the pendulum is what we're going to look at next. So for right now, just understand that mass does not change the motion or the period of the pendulum. So let's go back to only showing us our first one right here. And we've got a length of 2 meters. Okay, we have a length of 2 meters. What we're going to do is we are going to make both of our pendulums the same mass. So let's knock this one back down to 1 kilogram. Oops, my bad. That's the wrong one. Knock this back down to 1 kilogram. So our masses are the same size, our bobs are the same size, and our lengths are the same size. Okay? So we said before that mass does not play any sort of effect on the period of the pendulum. What we're going to change then is the length of the pendulum. So how far away from this central point that it is. So let's make this 1 meter. So we're going to make it half of the distance of the first one. So if we crank this one back out to our 50 degrees, and we move our second one out to 50 degrees, what I would like you to do is now record any differences you see in the period of the pendulum. So the time that it takes for it to reach all the way out to its furthest point and come all the way back. Which one moves faster? Which one moves slower? Do they move at the same pace? Ready? Go. Okay. At this point, you should have noticed that when you decrease the length of the pendulum, so when you make it shorter, your period is faster. Okay, so you have a shorter amount of time that it takes for it to go all the way out and come all the way back into you. True? True. So, that's what you should be writing down for your next one. Actually, let's bring them back to center. We're going to bring these both back to center. Boom. And we are going to make them actually, yeah, we're going to keep them just like this. So they're the same length, or not the same length, the same mass, but bob 2, so the red one, is half of the distance from its central point as the long one. Down here, we can change where the gravity is. So we've been doing it as if we would do it on Earth, right? Now the moon has 1/6 of our gravity, like literally 1/6 of it. What we're going to look at is how that changes the motion of the pendulum, how it affects the period of the pendulum. Okay? So we're going to swing these back out to our 50 degrees. I just choose 50 because it's a nice, easy number to work with. You can kind of see where everything's going with it, and it's far enough away to where you can notice everything. So remember, the gravity on the moon is 1/6 that of the Earth. That means it's a lot less, right? So that means there's less pulling down on these pendulums than there would be on Earth. So what we're going to do is we're going to look at how that changes these two pendulums. Ready? Go. Now, if you're watching this and you're kind of taking a look at it, you should notice that they both slowed down. They both slowed down, but Bob 2, or Pendulum 2, is still moving faster than the first pendulum, right? There is no point where they catch up to each other and stay going at the same pace. You might think it might have been right there at that point just a little bit ago, but it wasn't. They just crossed each other. So let's try this again, and we'll take it back out to the 50. Oops, to the 50. And let's take Jupiter. Jupiter is much more massive than the Earth, which means it has a bigger gravity to it. Okay, I think it's like 16 times that of the Earth or something like that. So all you need to know is that it has a much stronger pull on objects than what the Earth has. So if we saw that when we decreased the gravity, it slowed down the motion of our bobs, so it increased the amount of time, then what do we think would happen when we put these things on Jupiter? Should they go faster? Should they go slower? What should happen to our period? Take a look at it and write down any observations you see. If you notice, these things are like cruising. They're speed rocketing back and forth. Now, this makes sense because we said that the gravity on Jupiter is like 16 times that of the Earth. Now, because of that, it has a stronger pull on these bobs, right? That means that there are only two things that affect the motion of pendulums. And if we go back to here, if I flip over, we're going to see that Galileo actually found this stuff a long time ago. He found that mass has no effect on the period of a pendulum at all. In fact, the only difference depends on the length of the pendulum, which we found and we saw, and the acceleration of gravity, which we also saw. We saw how gravity affected it when it was on the moon, which is a lot less than what it is on Earth. And then we saw what happened when we compared it to that of Jupiter, which is much more massive than the Earth. So if you can get out of this that there are only two things that determine or make the, let's see, how do we rephrase that? If you can get out of this that the only difference in the period is dependent on the length of the pendulum and the acceleration of gravity, you're doing okay.